Hello everybody, my name is Mikhail Wasi and I'm going to be giving you a brief demonstration of what I've been working on in my undergrad research thus far. The recent meteoric advancements in large language models and natural language processing, especially over the last year, have opened up a huge pathway to revolutionize the way classical software works. These large language models can logically reason and comprehend natural textual input from humans. So my research focuses on this newfound power in large language models and integrating that with classical UI systems. We're all used to UI everywhere, in all applications on our phone or our computer. Everywhere that we go, we use classical UI systems. And by classical, I mean the typical mouse dragging, keyboard clicking. You have to follow the rules outlined by the developer when they made the software. For example, if you're using Excel, you have to follow the rules laid out by the developer in order to carry out commands and functions. If you want to highlight a row or move something or auto adjust your columns and rows, you have to do that by the way that the developer has set out. And maybe there's only 2 or 3 or 4 ways to do that. Maybe there's a shortcut, maybe there's a button command scheme that you have to follow, but that's it. You have to learn how they wanted you to do it. With the new large language model power, we can kind of make a middleman come in between the user and the end software. This middleman can take textual input from the user, comprehend it, extract from it what it needs based on the demands of the software. So my research focuses on creating a framework that integrates this whole idea and actually brings it to life. With this framework, we can evolve static UIs into logically capable and dynamic UIs and software systems. And such a framework, just applied across all industries and sectors, would greatly increase productivity, what people are capable of, reduce cognitive load, and just skyrocket efficiency. So with that brief background of the foundation of my research, you can understand that we're trying to bridge the gap between UI systems that classically exist and we're all used to, with the new power, harness the new power of large language models to create something that is the next generation of software. So now let's take a look at the project so far. We opened the application to be greeted with a nice simple UI. This is one of the simple applications that are available in our library so far. So you can see that these name, address, and email fields would operate as a normal application would. So we have classical UI, but then at the bottom we have a microphone symbol and enter your prompt. This is where my research comes in. This will be at the bottom of all the applications, and you can use this to traverse this sort of operating system type of framework. So let's try out a simple input where we're going to put in some ums and ahs to try and get a realistic convoluted order invariant input. I reside at 34 Coronation Street. My name is Connor Sile, and oh yeah, my email is connor32@gmail.com. So there you go, it got it. So let's try out another one. My email is john.smith@email.com, and oh yeah, my actual name is John Smith. If you want, you can send mail to 456 Oak Road, Lakeside. And there you go, it picked it up perfectly great. Now this is pretty cool on its own. You get to fully interact with an application through speech control. The large language engine integrated with my UI framework makes it so that each and every single component in an application knows its role. It knows what purpose it has to serve. It knows what it needs from the user, so it can extract and care about only what it needs from the user's input. I also mentioned that the framework kind of serves as an operating system, so I can carry out other tasks as I would if I was on a phone or a watch or a tablet or a computer. I can do different applications, like let's say I want to check the weather. So I'm in this account form and I go, oh wait, I have a flight to Norway. What is it like in Norway? And there you go, I get to see Oslo, Norway weather. -7 is what it's feeling like right now. It understood everything I wanted, it extracted it perfectly, and we can try another one. I have a meeting in Belgium at the Atomium. What do I need to wear? And there you go, we got Brussels, Belgium. Now what if I needed to just make calculations real quick? I don't have to switch the app, I don't have to pull out a calculator app, I don't have to even type. I can just speak my requests in the middle of my task that I'm currently doing. Multiply 789 by 56 and then deduct 4,321. There you go, you can see it literally doing the bed mass. It understood from my ordering of my operations and operands, how I wanted to conduct my sequence expression. It understood the bed mass and calculated it correctly. Now let's try to use the typing mechanism just for fun. Type in our prompts. There we go. Now let's just finish off with some more prompts, switching from application to application to just demonstrate, you know, the dynamic ability of this project. Triple the sum of 852 and 147. There you go, it understood the bed mass. What do we need outside in Toronto, Canada today? There you go. And there we go. So that's my research project and demonstration so far. Hopefully you found it and its potential half as exciting as I do. I'm super thankful and grateful for Ken, Poo, and Ali Nishati, my thesis advisors. Their guidance is fantastic and priceless. While my project has already come a long way, there's so many improvements to make, new technologies to integrate, new research to do on existing technologies that we already have integrated, different optimization techniques. There's so much research to do. And a huge focus for us is make some sort of system that either fine-tunes on demand or generates datasets on demand, automated system to just allow us to generalize perfectly well, so then when new applications are put into the library, we can generalize really well onto them without having to specifically fine-tune manually and create datasets manually. The automation of meta descriptions and annotations are also part of that, so that it eliminates manual labor entirely. That just makes for a super scalable system and next generation of software. The biggest step forward right now is to embellish the engine or try some different configurations for multi-modeling. Maybe have one model that can handle every task it generalizes really well, or have a multi-agent, you know, Microsoft's AutoGen, to employ models on a case-by-case basis, or use something like Mistral's Mixtral 8x7b expert model combination to try to generalize well. I hope any of this was at all inspiring. Any feedback and guidance is truly appreciated. Thank you.